A circle with the center C has an equation x minus 8 whole square plus y minus 4 whole square is equal to 100. Show that the point T minus 6 comma 6 is outside the circle, and this has 3 marks. Here in this question, the center of the circle is 8 comma 4 and the radius is 10. So this is the center. Let me write center here. Here the radius is 10, and show that this point, the T, is outside the circle. If this point T is outside the circle, suppose it is over here, therefore the distance CT will be greater than radius. So let's check it. The distance between two coordinates can be calculated. The distance can be calculated like this, using this formula of coordinate geometry: x2 minus x1 whole square plus y2 minus 1 whole square. So x2 8 and minus plus 6 whole square plus y2 minus y1 whole square it is under root 200, square root of 200, which is 14.14. So this distance C to T is 14.14, and this is greater than the radius, which is 10. So therefore CT, the distance CT is greater than the radius, because 14.14 is greater than 10. Therefore the point is outside the circle. In the B part of the same question, two tangents from point T to the circle are drawn. Show that angle between one of the tangents and CT is exactly 45 degrees. This question carries 2 marks. Let's draw the diagram. It is a circle with center 8 comma 4 given in the question, and the radius is 10. The point T is over here, minus 6 comma 6. Two tangents are drawn from this point, which is outside the circle, and we know from the theorem of circle, the radius, the angle between radius and the tangent is 90 degrees. And the size of the radius is 10. From the equation we can see this, from the equation of the circle given in the question. And the length of this green line, which is CT, we have just calculated in our last part A. It is under root 200 or 14.14. So as per our information from the part A, the length CT is 200, a square root of 200 mentioned here in the part A, or it is 14.14. So I took square root of 200 and mention over here. And these two triangles are right angle triangles. This is one right angle triangle and this is second right angle triangle, and both are congruent right angle triangle. So let me take one of them. So let me take this top one, and now I have to find, so I have to see the angle between the tangent, this tangent, and the CT. Here it is 45 degree. So I have to show it. So let's This is 90-degree angle. So this is hypotenuse. Okay. And this is the opposite side. So using SOHCAHTOA, I will apply here sine this angle is T. Let me call this angle theta here right now, is equal to opposite over hypotenuse 10 over square root of 200, and then I will take sine inverse and this is 45 degree. So it is proved the theta is 45 degree. So this is 45. Angle between one of the tangent and CT is exactly 45. Shown. Touch the circle at A and B. So these two red tangent lines touch the circle at A and B. Find the equation of line AB, giving your answer in the form y is equal to mx plus c. We have to find the equation of this blue line, bold blue line AB. Student, you can observe the angle which we have found in the part B. It is 45 degree. It's 45 degree. So this whole angle is 45 plus 45 because they are congruent angle. It is 90 degree angle. So this whole angle is 90 degree. And you know from the properties of circle, these two tangents are equal in length. Okay. So let's redraw this diagram. I'm taking this angle 90 degrees. So this is a circle again with center 8, 4, and these are the point where tangent touch the circle, and from the previous part we observed this angle is 90 degree, and from the theorems of the circle, angle property of the circle, these two sides are equal sides. The radius are 10, and the length, this CT, this point is T, is square root of 200. And we found this length square root of 200 in the part B. So it is better to find this length AT. So let's find this AT from the diagram of the last part. So this AT is basically this is hypotenuse, and this is we will use cos 45. It is equal to 80 over square root of 200, and 80 is square root of 200 times cos 45. And it is 10. Surprisingly, it is 10. Good. So this length is 10. So obviously this will be 10 as well. So let's move to the C part now. Okay, so now we have observed this length is also 10. Okay, 10 and 10. So obviously this diagram ATBC is a square. It's a square. Therefore, this line CT is the diagonal of the square, and the line AB, this line AB will also be the diagonal of the square. and from the diagonal properties of the square, they both will intersect at 90 degree, and they are the perpendicular bisector of each other. So it means this is the midpoint. So now we will find the midpoint of the line CT, and T is minus 6, comma 6. Therefore, midpoint of CT, okay, it is x1 plus x2 over 2, comma y1 plus y2 over 2, because these are the coordinates. So it is 2 over 2, that is 1, and 6, 10, and 10 over 2 is 5. So the midpoint 5. So the coordinate of these points are, we have found this point, this is 1, comma 5. Okay. Now we will find the gradient of line CT. The gradient of line CT. So the gradient of line CT, it is y2 minus y1, 4 plus 6 over 8, 4 minus 6, because y2 minus y1, or x2 minus plus. Okay, so it is minus 2 over 14, which is minus 1 over 7. And we know that the line AB is perpendicular to line CT. So the gradient of line line AB will be negative reciprocal of this, which is negative negative plus, which is 7. So the gradient of line AB is 7, and the point, this is the point which is on the line AB as well, 1, comma 5. So the equation of line will be y is equal to mx plus c, and y is m is 7x plus c. Just plug in this point, 5, 7 into 1 plus c. So 5 minus 7 is minus 2. So c is minus 2. So the final equation of the line AB is y is equal to 7x minus 2. This is the equation of line AB. Student, hope you understand.